Okay, welcome to the 4-6 notes. This is a section about isosceles and equilateral triangles, and we've already kind of talked about some properties of these triangles, but I want to make sure that we go a little bit in depth here and make sure we answer a lot of questions about them. The first thing I want to talk about is properties of an isosceles triangle. So if I have an isosceles triangle, so isosceles, and I think that's a good name for like a pet, isosceles. So, okay. But let's go ahead and just draw a generic isosceles triangle. And what I know about an isosceles triangle is that, let me call this triangle ABC. Okay, what we know about an isosceles triangle is that AB is congruent to BC. Okay, so we know that AB is congruent to BC, all right, in this. Okay, but what we also know here is that our base angles, angle A and angle C, are also congruent. Okay, so angle A is congruent to angle C. So what I want to write here is an if-then statement. So if a triangle is isosceles, okay, then two sides are congruent and the base angles are also congruent, okay? And these two angles here, all right, let me zoom in on this, okay? These two angles are the base angles, okay? These are our base angles. And when I mean base, that's really another word for bottom, okay? So our bottom angles, whatever the sides are that are congruent, okay, whatever these sides are, then the two bottom angles are the ones that are going to be congruent, okay? So that's a property of an isosceles triangle. Let's take a look at an equilateral triangle, okay, or an equiangular triangle. So I'm going to say equilateral triangle, okay? And remember what we know about that is that an equilateral triangle is one where, and I'm going to call this triangle DEF, okay? And so what I know here is that all of my sides are congruent, okay? That's what makes it an equilateral triangle. All sides are congruent. But what I also know is that all of my sides are congruent as well, okay? Or I'm sorry, all of my angles are congruent. So all my angles are congruent. So here's what I know. Okay, I would then say that DE is congruent to EF, okay, which is congruent to DF, okay? All those sides are congruent, okay? But then I also know this, that angle D is congruent to angle E, which is congruent to angle F. Now let's just go ahead here and say something like this. Okay, let's say that we don't know what these angles are. I'm going to call this X, X, and X. Okay, so if I wanted to find out the measure of these angles, okay, then I have this equation of X plus X plus X is equal to 180. Okay, and so I'm going to call that 3x is equal to 180. I'm going to divide that by 3 and divide that by 3. So I know that x is equal to 60. Okay, so each measure here is 60 degrees. Okay, and so if they're all equal, then they all have to be 60 degrees. All right, and so that's true for any equilateral triangle. Okay, so if you know it's equilateral, then we know all of these properties. Okay. So now let's go ahead and answer some questions here. And it wants us to refer to this figure on the right. And so for the first question, I've got if segment AC is congruent to AD. So I'm going to come here and I'm going to say that segment AC is congruent to AD. It wants us to name two congruent angles. Okay, and so I'd come here. And because those are the two segments, my base angles are here and here. So I would say this. I would say angle ACD is congruent to angle ADC. Okay, and that's what I've got. All right. Now, in part 2, okay, if it says that BE is congruent to BC, so let me make those statements here. Okay, those two segments are congruent. Okay, then my isosceles triangle is right here. Okay, and these two angles are my base angles. So let me zoom in on that and mark those off with, these are 2, okay? And so here's what I can say. I would say that angle BCE is congruent to angle BEC, angle BEC, okay? Okay, on the next one, I want to do, if angle EBA, so EBA is right here, EBA is congruent to EAB, okay, name the two congruent segments. So I'm going to come here and I'm going to zoom in here and call this has three little arc marks, okay? So then I would know that these two segments are my congruent segments, okay? So I know that AE is congruent to BE. So I'm going to go over here and say that AE, okay, AE is congruent to BE, okay? All right, and then the next one, the last one for this says if angle CED is congruent to CDE. All right, so let me come in here and do that. All right, and let me come in here and say CED. So these two angles, 1, 2, 3, 4. 1, 2, 3, 4. If those angles are congruent, then what segments are congruent? And so I would say that CE, 1, 2, 3, 4, CE and CD, 1, 2, 3, 4, those are the ones that are congruent. So let me come in here and say that CE is congruent to CD. So CE is congruent to CD. All right? All right, so now what I know here, okay, and so let's take a look at number 5 and just find each measure. So on number 5, I've got this triangle here, and I know that AC, so let me come in here and say that AC is congruent to AB, okay, and I know that those two are congruent. Then, because those two are congruent, I know that these two angles are congruent. Okay, and if this measure is 60 degrees here, then this one has to be 60, okay? And so that's what it's asking, okay? It was asking what's the measure of angle ABC, and because this is 60, this has to be 60 because these two segments are congruent. So the measure of angle ABC is equal to 60 degrees, all right? Okay, let's take a look at number 6. Okay, now I know this one's a little bit trickier, okay? It wants us to find angle EDF. So it wants us to find this angle right here. Now what I know, first off, is that ED is congruent to EF. I'm going to write that out, that ED is congruent to EF. Okay, so then I know that my base angles are going to be congruent, okay, and they're going to be the same. Now I don't know what they are. Okay, but I know that this angle is 40 degrees. Okay, so I'm going to come in here and I'm going to call this x because I don't know what it is. I have to assign it a variable. So I'm going to do this. I'm going to say that if I add x and x together, if I add those two angles and add 40 to that, then I'm going to get 180. Okay, now if I combine my like terms, I'm going to get 2x plus 40 is equal to 180. All right, I'm going to subtract 40 from both sides. And I end up getting that 2x is equal to 140. And so I'm going to divide by 2 and divide by 2, so then I get x is equal to 70 degrees, okay? So this angle here is 70 degrees, okay? So EDF is a 70-degree angle, okay? So just given that little bit of information, guys, we can find out a lot of other information about the other problems. Okay, all right, let's take a look. And in example 7 and 8, they want us to find the value of each variable. Now, in this problem, okay, I know that these two base angles are congruent. So if these two base angles are congruent, then I know that these two side lengths here have to be congruent, okay? And if those two segments are congruent, then I can set up an equation with 2x plus 4 is equal to 3x minus 10, okay? And then I'm going to subtract 2x from both sides, and I get 4 is equal to x minus 10. And if I add 10 to both sides, then I'm going to get that x is equal to 14, okay? And so I'm just trying to figure out what kind of equation can I set up to make this work, okay? So now let's take a look at number 8, all right? Now this one's a little bit interesting, okay? This one, I know that this is a right triangle and this is an isosceles triangle as well. So I automatically know that these two angles, okay, are congruent, all right? And what I know about the two angles in a right triangle, these two angles are complementary, okay, meaning they add to 90. So I'm just going to go ahead and call this angle, I'll just call it, I don't know, angle R. Okay, call this R. It doesn't matter what I call it. But I know this. I know that 2R is equal to 90 degrees. Okay, and if I divide that by 2 and divide that by 2, I get that R is equal to 45 degrees. Okay, so I know that these angles are 45-degree angles. Okay, and we're going to talk about these kinds of triangles at length. Okay, but I'm just trying to set up an equation here. Okay, and solve. So I'm going to set up 2x plus 3 and set that equal to 45 degrees. Okay. And so if I subtract 3 from both sides, then I get that 2x is equal to 42. Okay, and if I divide by 2 and divide by 2, I get that x is equal to 21. Okay, so, you know, a lot of really cool stuff here, guys. I really like isosceles triangles and equilateral triangles. They're some of my favorite triangles, and especially this one. Especially number 8. That one's really slick. We're going to look at that one quite a bit. So I hope you enjoyed this video. Go ahead and get started on your homework, and we will see you soon. Party on.